Hi everyone, it's Mrs. Brimlow, and today I'd like to teach you about perfect cubes and cube roots. So we've been talking a lot about perfect squares and square roots this week. So today we're going to move into cube roots, which are very similar. So you should have these notes out and you should be taking them along with the video. So name, date, and class. Okay. All right. So when we're thinking about a cube root or cubes, we're talking about three-dimensional figures. So I have this example here, and if you label it, you can see it has three different sides. It's got length, width, similar to a square rectangle, but it's also got height, which is what makes it three-dimensional, okay? And when we're talking about cubes specifically, all of their sides are the same length because the faces on each side of a cube are all squares, okay? So when we're trying to figure out the side length of a cube, which is what they want us to figure out, dimensions of each square piece that is 216 inches cubed. Notice they're using a 3 here because we're talking about a cube of a birdhouse, okay? So when we're talking about volume, we're talking about cubes, we're talking about three-dimensional space. So to find volume, I have to do side times side times side, okay? And specifically for a cube because all the sides, are the same. So I can basically simplify that to s to the power of 3 or s cubed, okay? All right, so what do we know? We know that the volume is 216, and we know that it's going to be equal to s to the power of 3. So the other sheet you should have and be using is this new resource, Perfect Squares and Square Root sheet. Specifically, you want to focus at the bottom. So I'm actually going to fold my paper in half so that I can just focus on those perfect cubes and cube roots, and even more specifically down here. So in order to figure out what S is, so what the side length is multiplied by itself 3 times, okay, I need to take the cube root of 216. So you're going to notice we're still using the radical symbol. The only difference is we put a 3 above what I like to call the tail of the radical because we're taking the cube root. So we have to let the person know who's looking at our work and for ourselves that it's cubed, okay? So if I look at my reference sheet, okay, I can see the cube root of 216 is 6. So that means that this is 6 inches each side length, okay? I'd like you to pause this video and I'd like you to try these 4 problems at the bottom. When you're all set, I'd like you to watch to check the answers with me, okay? So now that you've had a minute to try these problems, I want to go through each of them, and please make sure you have all the details down. So cube root of 64 is 4, and we know that because 4 times 4 times 4 is 64, okay? So once again, it's a number multiplied by itself 3 times. Cube root of 27 is 3, and that's because 3 times 3 times 3 is 27. Next, the cube root of 1,000 is 10, and that's because 10 times 10 times 10 equals 1,000. Now, cube root of -8. So I imagine most of you were able to figure this out. So looking at our chart, we know that the cube root of 8 is 2. And because it's negative, the answer is negative. And so just to prove it, using the same reasoning we used for the last 3, I'd have to do -2 times itself 3 times. Now, when I do that, I know 2 times 2 is 4, and a positive times a positive, same sign is positive. So then I'd bring down the last -2. So 4 times 2 is 8. Different signs, positive and negative, means my answer is negative. So when I have a cube root that's positive, the answer is positive. When I have a cube root that's negative, I just find the cube root of the number, and then I know my answer has to be negative as well, okay? So for the rest of class, you are going to work on the IXL strand posted in Canvas, and then you are going to work on your crossword puzzle if you haven't finished that yet, or read or work for other classes, okay? And we will review this next week when I come back. So thanks for watching, and I will see you guys soon.